number 2. We studied uh, Karzai bearing capacity equation and solved some examples in our lecture number 3. In lecture number 4, we would solve another example on Karzai bearing capacity equation, and then we would study Meyerhof bearing capacity equation, and then we will solve some problems on Meyerhof bearing capacity equation. So that is the target of our this lecture, inshallah. So this is last problem that we would be solving on Karzai bearing capacity equation. This is the statement of the problem. You go ahead and sketch a diagram of the foundation, apply these loads, write the soil properties on the diagram, and then use the Karzai bearing capacity equation and solve the problem yourself. Can you hear my voice and can you see the screen?
Yes, sir.
Yes,
Okay.
sir.
Okay. So read this problem, last problem on Karzai bearing capacity equation. Read this and first of all sketch a diagram and then write Karzai bearing capacity equation and solve for the unknown. I am giving you a couple of minutes. So this is the diagram and all data is shown on the diagram. Now you need to use the bearing capacity equation to find the required width of foundation that would ensure a factor of safety equals to 3 against shear failure. So here factor of safety is given, right? Load is given. You need to find the required width of foundation, B. ठीक है जो आंसर आ जाए मेरे साथ शेयर करें। जी क्या आंसर आया?
सर अभी बाकी है।
अच्छा अच्छा। अच्छा जी, you know that vector of safety is equal to Q ultimate over Q applied. Q applied is dead load and live load. Both together it is 800 kilonewton per meter. Because it is a strip footing, right? So the load is given in form of per meter run. Factor of safety is 3, right? Q ultimate we will find from Karzai bearing capacity equation, right? In terms of B, because B is unknown, and Q applied is taken from this 800 kilometer per meter. So this everything in this equation is known except the B value which comes in Q ultimate. So we can find QB from this equation. But one thing one has to remember that Q ultimate is in terms of stress, whereas Q applied here is in terms of per meter run, it is not in terms of stress. So we have to convert this per meter run load in terms of stress and put it in this equation. So can anybody tell me how can we convert a linear load into an area load, into a stress load? जी, कोई बता सकता है कि इस लीनियर लोड को स्ट्रेस में कैसे हम कन्वर्ट करेंगे?
सर फैक्टर ऑफ सेफ्टी मल्टीप्लाई बाय अप्लाइड जो होता है इस
जी
तरह होता है।
जी बताएं।
सर हम जो क्यों अल्टीमेट जब मालूम करते हैं तो फैक्टर ऑफ सेफ्टी मल्टीप्लाई बाय क्यों अप्लाइड करते हैं।
जी
तो
नहीं,
क्यों
ये
अप्लाइड जो होता है
जी जी जी
क्यों अप्लाइड जो होते हैं हम डेड लोड प्लस लाइव लोड करते हैं तो इससे 800 आता है। 800 मल्टीप्लाई बाई फैक्टर ऑफ सेफ्टी जो होता है वो 3 है। तो इससे हमारे साथ क्यों अल्टीमेट आ जाएगा। मल्टीप्लाई बाई विड्थ भी करते हैं क्योंकि इसके साथ हमारे साथ क्यों अल्टीमेट इन टर्म ऑफ विड्थ आ जाएगा मतलब बी।
अच्छा अच्छा, आगे देखिए मैं क्या करता हूँ। Q ultimate is factor of safety into Q applied. Factor of safety is equal to 3 and Q applied is 800, 500 plus 300 divided by B. By dividing this 800 by B, you convert this linear load into stress. So Q ultimate is equal to 2400 over B. But we have another equation for Q ultimate, which is from Tarzahi bearing capacity equation. This is Tarzahi bearing capacity equation. This will also give you Q ultimate. Or you can put, instead of QU, you can put 2400 over B here, right? Put this value here, you will get this. This first term, second term and third term. You have to incorporate the effect of water table as well. Water table is at the ground level. When water table is at the ground level, the second term is not affected, the third term is affected. So the second term here, the unit weight above the water table is 17. So you use 17 for this second term. But for the third term, you have to use submerged unit weight. 20 is the saturated unit weight minus 9.8 is 10.2. So here gamma prime in third term you have to use submerged unit weight. Since it is a strip footing, so shape factor R1, so it's not included here because it's already a strip footing. So put in all the values here and find the value of B. This is in quadratic term, so you solve a quadratic equation. You will get two values, so the one with a positive sign will give you the answer. It is 1.42 meter. If you have any question, you can ask. Now we will move on to Meyerhof bearing capacity equation. The Tarzai bearing capacity equation had some limitations in that it is applicable only to vertical loads. Vertical loads which has no eccentricity, which has no inclination. Remember that when vertical load is inclined, it has a horizontal component. So Tarzai bearing capacity equation is not applicable for cases where there is a horizontal load on the foundation or if there is a moment on the foundation. Meyerhof bearing capacity equation has all these factors included. So we would now discuss Meyerhof bearing capacity equation. In this diagram, on the right side, Meyerhof failure mechanism is shown. This is the failure mechanism assumed by Meyerhof. On the left side, it is the same old Tarzai bearing capacity failure mechanism. In Tarzai bearing capacity failure mechanism, we assumed a wedge. You see this wedge. This is a log spiral, and then there is a straight line, and the shear planes terminate on the foundation level. They are not assumed to propagate up to the ground surface. No, they are terminated at the foundation level. And the overburden pressure is taken to be equal to Q is equal to gamma D. Whereas in Meyerhof, elastic wedge and then a log spiral that moves up to the ground surface. This dotted shows that failure mechanism and the wedge. Another difference is in taking the wedge angle. The wedge angle assumed by Tarzai is equal to phi, whereas that assumed by Meyerhof is 45 plus phi by 2. So based upon this shear failure mechanism, Meyerhof derived his equation and bearing capacity factors. The bearing capacity equation derived by Meyerhof is in principle the same. It has three terms: first term, second term, and third term. First term is due to cohesion, second term is due to surcharge, and third term is due to self-weight of the soil under the foundation. Same three terms. You can see the red font. These are the same terms that were used by the Tarzai. Additional terms are shown in blue. In blue, every term is multiplied by 3 terms. SC, SI, are the shape factors. These are called shape factors. They take into account the shape of the foundation. SC is the one that is multiplied with the cohesion term. SQ is the term multiplied with the surcharge term, and S gamma is the term multiplied with the self-weight term. Similarly, there is another term which is D, which was absent in the Tarzahi, D term. DC, DQ, and D gamma. This is called depth factor. So, by using depth factor, even if your foundation is deeper than the breadth of the foundation, you can use this equation. Whereas in Tarzahi, it was applicable only to those foundations which are shallow, which are very shallow, where the depth of foundation is less than or equal to the breadth of footing. But here, even if the depth is greater than the width of the footing, you can use these depth factors to take into account the effect of the depth. The last term is the I term, IC, IQ, and I gamma. These are the inclination factors. So if there is inclination in the foundation, in the load, inclination means there is a horizontal load and a vertical load, because it is the horizontal load that would cause an inclination in the resultant. So this, through these inclination factors, you can take into account the inclination of the loads that would affect the bearing capacity. There is one more term which is new, that is called B prime. You see that B prime was not used in Tarzahi bearing capacity equation, but here it is. B prime is called effective width of foundation. It is a reduced width of foundation. This takes into account the overturning moment or eccentricity, because due to eccentricity of the load, there will be a moment on the foundation, right? So this B prime takes into account the effect of that moment on the bearing capacity. So all these terms are here. NC, NQ, and gamma are bearing capacity factors. SC, SQ, S gamma are shape factors. These are depth factors, and these are inclination factors. So the bearing capacity factor NC, NQ, and N gamma, they are different than those proposed by Tarzahi, because NC, NQ, and gamma depend upon the failure mechanism that is taken into account, and the failure mechanism assumed by Meyerhof is different than that of Tarzahi. In Tarzahi bearing capacity factor, you use a table or a graph, right, to find NC, NQ, and gamma, but in Meyerhof he has equations. So first of all, you take a screenshot of this equation or write it down with you, so that when we solve problem, you have this equation ready with you. You can write it, or you can take a picture, a screenshot. जी लिख लिया है?
Yes, sir.
Yes, sir.
अच्छा, सो इसका भी फिर आप लिख लें या अपने साथ स्क्रीनशॉट ले लें. Bearing capacity factors, these are the equations that you can use to find the bearing capacity factors. They only depend upon the phi angle. shape factors. SC is equal to this, where B prime and L prime, that would be explained later, they are the effective footing dimension. B is the width of the footing, L is the length of the footing. These are the effective footing dimension. Kp is the passive coefficient, lateral earth pressure coefficient, equal to this. These are equation for SQ and S gamma. This equation for phi greater than 10 degree, and this for phi equal to 0 degree. For any intermediate value, you can interpolate. These are depth factors. DC, you can find D. This D is depth of foundation, right? This is B prime, effective width, and this equation is for phi greater than 10 degree, and when phi is equal to 0, you have 1. For any phi, this is not, this is by mistake. Okay, we would remove this. So take a screenshot or write it down with you so that we move on to inclination factors. लिख लिया है?
नो सर।
अच्छा, लिख लें लिखना अच्छा है।
सर हो गया।
अच्छा, now inclination factors. This is a vertical load, this is horizontal load on the foundation, and this is the resultant. This is angle theta that the resultant would make with the vertical. So I say IQ would be is equal to this, theta over 90 degree square, whereas I gamma is equal to 1 minus theta over phi. Whereas I gamma is equal to 0 for phi is equal to 0 degree. So these are the inclination factor. Write them down with you. Now, all the terms in the Meyerhof bearing capacity equation have been explained, and the factors are given, except one thing which has which requires some explanation. Can anybody tell me what is that which still requires some explanation, which is not explained yet? This is the Merhab bearing capacity equation. All the terms have been explained and the equation given. Only one parameter is still to be explained. Can anybody tell me which is that parameter?
B prime, sir.
G?
B prime.
B prime. So this is called effective width of foundation. Whenever there is a bending moment or eccentricity of load, the width of the foundation is reduced by some equation, so that that reduction in bearing capacity due to moment is taken into account, because when there is eccentricity on of the load, there will be a bending, there will be an overturning moment on the foundation, and it will reduce the bearing capacity. So that reduction in bearing capacity is taken into account using a reduced width of foundation, B prime. So let's explain this. This is the footing. This is length of the footing, and this is breadth of the footing. This is center of the footing. And this is load. And you can see this load is not applied at center, rather it is off-centric, it is eccentric. It has a eccentricity in the L direction. This is L, EL. Eccentricity is EL in the L direction. And eccentricity of load is EB in the B direction. So here the load is applied at eccentricity EL and EB. So this load would cause a moment both in the vertical and the along the L axis and along the B axis. To make this eccentric load as concentric, you have to remove this portion. You have to ignore this portion of the foundation. That is 2EB in the B direction and 2EL in the L direction. Once you ignore this load would automatically become concentric, but with reduced footing dimension, which are this white. So this dimension would be B prime, which is B minus 2EB. And this dimension would be L prime, L minus 2EL. Here, same diagram. B prime would be equal to B minus 2EB. L prime would be equal to L minus 2EL. So this is effective width, this is effective length. Remember that B prime is the one that is less. So the value which is less would be equal to B prime. So B prime should be less than L prime. If B prime is greater than, the value of B prime is greater than L prime, then you have to swap the values. Means you assign least value to B prime and greater value to L prime. Effective area of the foundation would be equal to B prime into L prime. So this reduced area should be used to transfer the vertical loads to the ground. if you have, instead of eccentricity, moments are given in the L and the B direction, so you multiply the moment with the vertical load to get EB, and multiply the moment in the L direction by the vertical load to find EL. So by using B prime is equal to B minus 2EB, you can use this B prime in the Merhoff bearing capacity equation. So if you have any question, you can ask. Then we are going to solve a problem on Merhoff bearing capacity equation. Okay. So you have written all the equations with you. Now you should be able to solve the problem yourself. Just use these equations. So this is a problem. You need to find allowable soil pressure, factor of safety 3, using Merhoff bearing capacity equation. So you have Merhoff bearing capacity equation. That equation would give you ultimate bearing capacity. Divide that by factor of safety 3 to get allowable soil pressure. This is the problem. The depth of foundation is 1.8 meter. This is a square footing. B is 1.8 meter and length is also 1.8 meter. Look, B 1.8 meter, length is 1.8 meter. Friction angle 36-degree, cohesion 20 kPa, unit weight of soil is 18 kilonewton per meter cube. We have a moment in the B direction. This is B. The moment in the B direction is 360 kilonewton meter. The moment in the L direction, which is perpendicular to the screen here, but here it is shown, is 450 kilonewton meter. So you go ahead and solve this problem. I'm giving you 5 to 10 minutes. You solve it yourself. All equations are with you. You solve it yourself. And we will meet after 10 minutes. In the meanwhile, if you have any question, you can ask. So these are the eccentricities that you can find. जी क्या आंसर आया? जी व्हाट इज द आंसर? जी क्या आंसर आया है? आर यू देयर?
सर ये सर लेकिन बहुत लेंथी है, हल कर रहे हैं सर।
अच्छा अच्छा, यहाँ तक तो समझ गए ना, ये जो मैंने डिस्प्ले किया है।
बस शेप फैक्टर मालूम किया अभी तक।
ये
अब
जो
मालूम
मैंने
करते हैं।
डिस्प्ले किया है, इफेक्टिव फुटिंग डायमेंशन, इफेक्ट ऑफ वाटर टेबल, इसकी तो समझ आ गई है।
यस सर, यस सर, यस सर।
ये भी चेक करें।
सर ये अफेक्टिव विड्थ और लेंथ जो होता है ये तो डिफरेंट वैल्यू आता है, हमसे 2.2 और 2.3 आ गया है।
चेक कर लेना कहाँ पे आप पर। मोमेंट्स आपकी एक्सेंट्रिसिटी यही है, ई बी और ई एल। ये एक्सेंट्रिसिटी है।
यस सर, ये तो इसी तरह है, बिल्कुल ये तो ठीक है।
जब ये ठीक है तो ये भी ठीक आने चाहिए। अब ठीक आ रहा है, 1.4 1.3 ही आ रहा है आपका।
ये हमसे गलती हो गई, मैंने जमा कर दिया। यस सर,
नहीं
बस
नहीं,
आप बोला ठीक
ये
है।
रिड्यूस करना है क्योंकि बेरिंग कैपेसिटी एक्सेंट्रिसिटीज की वजह से रिड्यूस हो जाती है, तो बी प्राइम कम होना चाहिए। ये वैल्यूज चेक करें, यही आ रही है।
यस सर, ये तो ठीक है, ये ठीक है।
समय सलीमा तक कॉल लो। अच्छा जी, ये शेप फैक्टर आ रही है आपकी।
Yes, sir.
डेप्थ फैक्टर्स, चेक द डेप्थ फैक्टर। अच्छा जी, डेप्थ फैक्टर भी आपकी यहीं आ रही है।
Yes, sir.
अब बताएं इंक्लिनेशन फैक्टर्स क्या होंगे। देयर इज नो लोड इंक्लिनेशन, इट इज वर्टिकल लोड। इंक्लिनेशन फैक्टर्स की क्या वैल्यू होगी?
तो सर वो 1 होगा, 1 नहीं
1
होगा?
होगी, कोई फर्क नहीं है। No inclination of load, so all factors are 1. Now put all these values in the Meyerhof bearing capacity equation. Write the Meyerhof bearing capacity equation. Put in all the values, you will get these. So complete this problem so that we move on to next problem. कोई क्वेश्चन है तो पूछ ले। So we are going to solve next problem, but try to solve this problem all by yourself and give me the final answer. This is the statement of the problem. Read this statement, draw a diagram of a retaining wall, show all these forces on it, and give me the bearing capacity. First of all, draw the diagram. Put all the values data on the diagram, right? Again, I'm going to give you 10 minutes. In 10 minutes, you should be able to solve this problem. All equations are the same. But in this problem, one factor of safety is required. ये डायग्राम है. It is a long retaining wall perpendicular to the screen. It has a vertical load component in kilonewton per meter run. It has a horizontal component of force on the foundation. The eccentricity of the vertical load is 0.36 meter. So here inclination factor will also be involved because the load resultant is inclined at an angle theta, and there is an eccentricity as well. These are the soil properties. This is the depth of foundation. Now things should be very easy for you. जी कुछ प्रोग्रेस हुई है? शेप फैक्टर्स क्या होंगे? व्हाट इज द शेप फैक्टर विद यू? जी शेप फैक्टर्स क्या वैल्यू है? जी shape factors, because it is a long retaining wall perpendicular to the screen L would be very large. In the shape factor, we have a term B prime over L prime. So when L is very large compared to B, B by L would be near to 0. And when you put in that equation B by L equal to 0, all shape factor would become 1. Now you can find depth factors similar to the last problem. You can find inclination factors. So you have a horizontal load and a vertical load. Horizontal load is 102, vertical load is 282. The angle that the resultant would make with the vertical is 19.8 degrees. Put them in these equations, you will get inclination factors. Now put all these values in the Meyerhof bearing capacity equation. You will get ultimate bearing capacity. Remember that, see these factors, how much they are going to reduce the bearing capacity. So inclination has a huge effect on the ultimate value of the bearing capacity. Now you got the ultimate bearing capacity. Now you find the factor of safety yourself from this ultimate bearing capacity and tell me what is the factor of safety against shear failure. जी फैक्टर ऑफ सेफ्टी की क्या वैल्यू आई है? What is the value of factor of safety? Connection हो जाए? This is the ultimate bearing capacity. You can find ultimate load per meter run from this ultimate capacity. Ultimate load would be QU into B prime. B prime is 2.28 and Q ultimate is 563. The ultimate load is 1283 kilonewton per meter. It is 1283 kilonewton per meter. Here is per meter as well. Now you got the ultimate load. The applied vertical load is 282 kilonewton per meter. So factor of safety is PU ultimate and P applied. It is this and applied load is this. The factor of safety is 4.5. If you have any question, you can ask. Otherwise, we would move to another topic. There is an alternate approach to consider eccentric loading. There is an alternate method how to take into account the effect of eccentricity or moment in the design of foundation. Remember that the bending moment or eccentricity would cause maximum stress on one side of the footing and minimum stress on the other side of the footing. So this is the equation for a strip footing. Q maximum is the maximum stress in the soil caused by the eccentric load. Eccentric load is Q per meter run. P is the width of footing. E is the eccentricity. So using this equation, you can find the maximum stress on the soil due to eccentric load. That stress should be less than allowable bearing capacity. And this is the minimum stress. By replacing positive when negative, you would get the minimum stress. This is applicable for a strip footing. You can prove this equation very easily. Here is a proof. This is a strip footing. The width is B, but the length is very long. This is the load per meter run, and this is the moment. The moment is generated because of the eccentricity of this load. So the stresses in the soil would be because of one due to this red axial load and the other is due to moment. The stress in the soil due to axial load will be uniform stress due to axial load. E would be equal to Q divided by A, area of the foundation. But if you take per meter run, you see this per meter run, so that A would be equal to B into 1. So QP would be equal to Q divided by B. And because of this moment, the stresses would be flexural stresses. Here you would have a positive stress compression, and here you would have a negative. The final stress in the ground would be summation of these two stresses. What would be this coordinate equal to? Can anybody tell me how to find this flexural stress because of this moment? E. This is MC over I, the same old equation that you use in the beat. You sum these two up and you will get the final stress. Here, these two stresses, this is positive, would add up and maximum would be obtained. And here, this stress would be subtracted from this stress and a minimum stress would be obtained. Q minimum and Q maximum. This is with the positive sign, this is with the negative sign. Now, we know area is B into 1. C is B by 2. C is the distance from the neutral axis to the farthest fiber portion of the soil under foundation. Moment is equal to Q into E. E is the eccentricity of the load. Moment of inertia is B cubed into 1 by 12. So put this is the Q maximum and Q minimum equation. Put these values in this equation and you would get this equation. The same equation which was given in the previous slide. So this is applicable for a strip foundation. You have any? This Q maximum must be less than Q allowable or equal to allowable, less than or equal to the Q allowable for a safe design. If you have any question, you can ask. Otherwise, we are going to solve a problem on this method. Now this is the problem. You solve it yourself. जी क्या आंसर आया है? जी जी आपको मेरी आवाज आ रही है?
यस सर।
यार कुछ तो बताएं ना। इक्वेशन आपके पास है, सिर्फ वैल्यूज डालें और मुझे बताएं क्या आंसर आ रहा है। ये इक्वेशन है ना, ये वाला इक्वेशन है, ये क्यू मैक्सिमम ये क्यू मिनिमम है, ये इक्वेशन है, वैल्यूज दी गई हैं, इसमें सिर्फ प्लग इन करें और आंसर निकालें। ये लिखे अपने साथ। लिख लिया है इक्वेशन?
Yes, sir. Yes,
लिया
sir.
है जी।
Yes, sir.
अब ये इक्वेशन यहाँ इस वैल्यू पे अप्लाई करें। क्या आ रहा है क्यू मैक्सिमम और क्यू मिनिमम? जी क्या आया है? कैलकुलेटर नहीं है आपके पास? या कहीं
Sir, Q maximum 1.76.
जी जी
1.76, sir. Q maximum.
So is Q maximum acceptable from an allowable capacity standpoint? Is this foundation okay or not?
ओके सर।
क्यों क्यों ओके है?
क्यों मैक्सिमम ज्यादा है सर? क्यों इससे?
तो ज्यादा है ना, तो अप्लाइड स्ट्रेस ज्यादा है और अलाउबल स्ट्रेस कम है, तो ओके कैसे हो सकता है? Since Q maximum is greater than QS safe, Q maximum is not acceptable. ये फाउंडेशन डिजाइन ठीक नहीं है।
यस सर सॉरी वो कंफ्यूज हो गया।
है ना बेटा? अच्छा जी, तो इससे हमारा बस यहीं तक हम कर लेते हैं, ठीक है ना?
Yes, sir.
अटेंडेंस दे बस जाए, अटेंडेंस शवे वलीउल्लाह